So what we have here is three identical pipes joined by a T-connector in between them. Now think distribution of mass in these pipes. Because it is an irregular shaped object, there is no K value that you can just look up in a textbook. We did a lab. The purpose of our lab was to find the moment of inertia for these pipes. Our setup, we had a ring stand down the middle of the pipe in the middle. Picture that. This ring stand was all on a table. We had a string wrapped around this pipe here in the middle. It goes out to a pulley. Pulley is negligible friction, negligible mass. Around the pulley, there is a mass on the end of the string. You know the mass here. You know the distance between the ground here and the floor. You know the radius of this pipe actually. And what we did was we measured the time it took for this mass to drop to hit the floor, which caused this to rotate. We knew distance, mass, time, and radius. So how would you find the moment of inertia? Start off with torque equals moment of inertia times angular acceleration. Rearrange it for I equals torque over angular acceleration. Torque equals force multiplied by distance, like it always has, which is tension times radius. Tension we don't know. Tension is equal to the weight of the weight minus its mass times its acceleration. This is Newton's second law. We still don't know its linear acceleration. Its acceleration equals 2d over t squared, derived from a number of kinematics equations. Angular acceleration we still have to solve for. It equals normal acceleration over radius, like it always has. Combine all these equations to solve for I in terms of variables that we know. We have I equals mg minus 2d over t squared, brackets, r squared, all over acceleration. This is theoretically what I equals in terms of the variables we know in this lab. So right here we have a table, mass, time, and moment of inertia. Mass is your independent variable, time is what we measured, I is what we calculated theoretically due to this equation. The number of points on a graph here that. Points were about like this. We drew a line of best fit. Looked like this. The slope of this line, we had torque over angular acceleration. That equals moment of inertia. Slope equals I. We had rise over run, which is about 9.5 on top of 7.0 times 10 to the negative 3, which equaled 1,360. Correct units, kilograms, meters squared. This is your I value, as we've calculated.